Separating mixtures involves physical means or physical changes. No chemical reactions are needed to separate the components of a mixture because the components are not bonded. They're not chemically bonded to each other, so we don't have to do a chemical reaction. So, several ways to separate mixtures include sorting. And we can sort the components according to their color, their shape, their texture, and so on. We could use a filter. And of course a filter is based on the components of the mixture having different sized particles. Gravel, for example, or rocks, those particles are different size than sand particles. So if we had the right size filter, we could separate those two rather easily. The sand would go through, the rocks would stay behind. You might do some filtration in the chemistry laboratory, and it might involve some filter paper. It might involve a long stem funnel. You see those here in the upper right. Gravity filtration, we call that. You might do some vacuum filtration, use something called a Buchner funnel. There are any number of filtration methods that are useful in a chemistry laboratory. Even if you don't use filtration in a chemistry laboratory, you certainly do in the real world. In the upper right, most people have made coffee or seen it made. You definitely use filtration there. Most of us have made pasta. We need a colander to filter the cooked pasta from the water solution that it was cooked in. On the left, this is a testing device for determining the size of sand particles that are mixed into concrete. And in the lower right, that is a device for separating the aggregate, the gravel that's used in concrete. You might not be aware that concrete requires certain mass percentages of gravel of a certain size. And if the gravel doesn't meet those parameters, then it can't be used in making of concrete. Same with sand. We could separate the components of a mixture using a magnet if one of the components contains iron. Chromatography is based on the idea that some substances dissolve more easily than others. There are several types of chromatography, there are several offshoots and derivations of chromatography, but it's based on the idea that some substances dissolve more easily and therefore migrate further in a given medium than do others. We could separate the components of a mixture based on their density. Some things might sink while others float, for example. We might use a centrifuge, which is a device that will spin a sample at high speed, and the more dense component will sink to the bottom, and the less dense component will tend to stay at the top. Blood, for example, is a mixture, and the components of blood can be separated. If blood is subjected to a high-speed centrifuge, the red blood cells are slightly more dense and they will be at the bottom, and the blood plasma, being slightly less dense, will stay at the top. If two things have different densities and we want to separate most of one component from most of the other, we can decant the liquid. This would be a good technique to use if you wanted to separate, say, sand from water. The sand is mostly at the bottom, and if you just simply pour off most of the water, you can very quickly separate most of the water from most of the sand. It's a fancy term, decant, which means pour off the liquid. We can separate the components of a mixture using distillation, and this is based on the fact that the components of the mixture have different boiling points. So here's a picture of a distillation apparatus, and we have here, right above the flame, the mixture, and as we heat that, the more volatile substance, that is the one with the lower boiling point, will vaporize first and will migrate up here and into this condenser. And this condenser is surrounded by a chamber in which we pump water in, and then the water drains out, and that water that goes in cools that vapor, makes it condense, and then it drips out down here on the right. Now, of course, you have to shut the heat source off at the right time, because if you just let it go all night, then the entire mixture will end up over here on the right, and you won't have accomplished your goal. So the way you know when to shut the heat source off is by this temperature here. Let's summarize separating mixtures. 1. No chemical reactions are necessary to separate the components of any mixture because, by definition, a mixture consists of various components that are not chemically bonded to each other. Thus, all mixtures are separated by physical means, not chemical means. 2. Various methods to separate the components of a mixture include sorting, filtration, magnetism, chromatography, density, and distillation.